Here we go. This problem says that a store mixes Kentucky Bluegrass worth $10 per pound and Chewing's Fescue worth $13 per pound. The mixture is to sell for $12 per pound. How much of each should be used to make a 228-pound mixture? All right, so what we're looking for is how much of each of the Kentucky Bluegrass and the Chewing's Fescue do we need to make a 228-pound mixture? So we're going to set this up using two variables. We're going to let x equal to the number of pounds of Kentucky Bluegrass. We're going to let y equal to the number of pounds of this fescue. Now we do know that when you mix these two together, you're going to end up with a 228-pound mixture. So we have x plus y, the number of pounds of each, will equal to 228. And we get that just from the very last sentence there. Now we're setting up a system of equations because we have two variables, so we're going to have two equations. And this will be the first equation. Now to get the second equation, we need to somehow figure out the cost, or rather the value of each of these different, the Kentucky Bluegrass and the Chewing's Fescue. And the best way to do that is to set up a table where we can calculate the value of the Kentucky Bluegrass and the value of the Fescue. We can do that with this little formula that says the cost per pound times the number of pounds is equal to the value of each individual item here. Well, we know a lot of the information that goes in this table. The Kentucky Bluegrass, it costs $10 a pound, so that's 10. And the number of pounds, well, we said that was x. So that means that the value of the Kentucky Bluegrass will be 10 times x, 10x. And for the fescue, we know the cost per pound is 13. So we have $13 a pound, and it's y pounds. So the value would be 13 times y, or 13y. And the mixture, we know that the mixture is going to sell for $12 a pound. And we know that we have 228 pounds. We don't have to put x plus y here because we know that x plus y is 228, which means that the value of the mixture is 12 times 228, and 12 times 228 is 2736. Now we're going to use this information to come up with a second equation. And the key to that is to know that if you take the value of the Kentucky Bluegrass plus the value of the fescue, those add together to give you the value of the mixture. So what we're going to do is add these and then set that equal to that. Add these two, and it has to equal to the value of the mixture. So we have 10x plus 13y is equal to 2736. So that's the second equation. So the first equation, remember, was x plus y is equal to 228. Now we have a system of equations. There's a number of ways to solve it. What I'm going to do here is just solve it by the elimination method. So we can eliminate the x by multiplying everything in the second equation by a negative 10. So that means the first equation will stay the same. The second equation, if we multiply everything by negative 10, will be negative 10x minus 13y is equal to a negative 2280, negative 2280. So now we add these two together. The x's cancel, and this should have been a 10, not a 13, because we didn't want to cancel. The y's don't cancel also. The x's cancel, but 13y minus 10y gives us 3y. 2736 and 2280. When you add those together, you get 456. And then we divide both sides by 3. 456 divided by 3 gives us 152. Now remember that y represented the number of pounds of that fescue. So that's one of the quantities we were looking for. And the other one was, of course, the number of pounds of Kentucky bluegrass. Well, the first equation we came up with was x plus y is equal to 228. We're just going to take the y we just found and plug it into this. X plus 152 is equal to 228. If you subtract 152 from both sides, we get x is equal to 76. And remember, 76 was the number of pounds of that Kentucky bluegrass. So those are the two things we have to mix together: 152 pounds of fescue, 76 pounds of Kentucky bluegrass, and we'll get that mixture that would be valued at $12 a pound, which is what we were looking for. Okay.